Hello, good afternoon. My name is Fernando, and today I'm going to explain to you the subject of capacitance. Most likely, here I have here little notes that says that the capacitance is the ability of a body that it can store a little bit of energy or charge. In this case, most likely it's electrical charge. It can be of two types. It can be a self-capacitance or a mutual capacitance. I'm sorry. Over here I have these two post-its that has the formula for the first one, the self-capacitance, and the mutual capacitance over here. We can know that the formula it's C equals charge with B. And this one it can be for the same of them. Okay? Most likely this theme is this subject is about the ability that has this capacitors to absorb energy or electrical charges. Okay? So most likely I have a problem over here that it says what is the radius of an isolated spherical conductor that has a capacitance of 1.00. Most likely in this case we know that the capacitance is directly proportional to the radius, so most likely we can do that these ones are proportional. Okay, so in this case we have the first formula that we can use on the problem, that is going to be C equals 4 pi with epsilon 0, this multiplying the R. I'm sorry if the markers are not working correctly. Another point that we can deduce for this problem is that epsilon 0 equals 8.85 times 10 to the minus 12. This is okay. So this one is a value that on the problem we're gonna substitute for this one, okay? And then we have another formula, or we can deduce this one that is most likely that R equals C under 4 pi epsilon 0, okay? So the problem says that what is the radius? So what we're looking at the beginning is going to be the radius. We're looking this, and it says of an insulated spherical conductor that has a capacitance of 1. Okay? So we know in this case that the capacitance C equals 1. Okay? In this case, then we know the value that comes from pi, which is 3.14. We know the value that epsilon 0 has, epsilon sub 0, and then we are looking for the radius. So most likely what we're going to do right now is that the radius is going to be equals to 1 point. This is going to be divided by 4, 3.14, 8.85 times 10 to the minus 12. Okay? Let me take, that's going to be so in this case, I'm sorry. It's 1 divided 4 pi 8.85 times 10 to the minus 12. So I have over here that the radius in this case is going to be 8.9918 times 10 to the 9. Over here I have another explanation about what is most likely the capacitance and the subject. We know, as I told you at the beginning, that my charge equals C times V. This is the equation for the capacitor. And then we can deduce that V, or V, this one, equals Q under C. So it's a charge on the capacitor. We have a little circuit over here that from here we say the V battery is the one that is giving charge to all this circuit. Never mind, don't take this part, only the capacitor 1, 2, and 3. So what we're looking for the explication here is this part, and this part. So it's most likely we're looking what are the same of each capacitor in parallel. So it's this part. So most likely what we're going to be looking is the voltage. But we know that it is going to be the voltage of the battery because we have the charge over here. So it's here back. N equals the first voltage that we have plus the second voltage plus the third voltage. Okay? Now that we have all this, we can look for the total charge, which is Q. So in this case, since we have these parts in the charges, we have the total charge from the voltage 1 is going to be this one equals 1 total charge, charge number 2 and charge 3. So in this case, we remember that the Q, or the charge, equals this. So we can deduce right now that this one, equals the capacitor in voltage 1 plus the capacitor in voltage 2 plus the capacitor in voltage 3. So in this case we can take off the C because it's multiplying every V. So most likely what we can do is now we can take off the voltage because this voltage are the same once it's like sum over here. So most likely it's going to stay as C1 plus C2 plus C3. All this since we factorize the voltage for the voltage of the battery. This is not a problem. This is an example that I use to complete all the subject that we have over here. So this was capacitance. We have a lot of harder problems, but this one is the easiest one that I found. So I can explain you most likely what is the radius, the capacitor, and how the components work with the formulas. Thank you.